Welcome. Part 2. Let's go. Look at the right hand side of the board. You can see the formula for the rate constant, the formula for the temperature, the final temperature, and the formula for the activation energy is written at the board. Remember, in the part 2 of the video, I went extensively improving these formulas. Now we are on to the problem proper. All you need is these 3 formulas. Whatever they ask you, just copy it and paste. Punch your calculator and the answer will flow naturally. Let's go. We have a question. The activation energy of a reaction was found to be, so given on the question, given the activation energy, the EA, is 52.04. And remember, I just said something. You have the activation energy, and they gave you the SI unit. Please always be careful, is in kilojoules per mole. Now, the activation energy must always be in joules per mole. Must always be in joules per mole. Therefore, from here, you have to times it by 1000. Whenever the activation energy is in kilojoules, you times by 1000. Now, let's continue. So, times by 1000 means that this will now change to 52.04 times 10 raised to the power of 3 joules per mole. Now, the next thing is, if the rate constant, which is the K1, if the rate constant at 40 degrees, so we have our T1 to be 40, we have 40 degrees centigrade plus 273 because it has to be in Kelvin. Now, here the rate constant given is 5.76 times 10 raised to the power of minus 3. Now, they want you to calculate the rate constant at 55 degrees. So the second temperature, the T2, is at 550 degrees plus 273. Now, the next thing I'm going to do is immediately I convert my temperature to Kelvin. The next thing you impute. So the first temperature will give you 313 and 328. So this is 313, 328. And this one is in Kelvin. Beautiful. Now all you need to do, I said this in the part 1 of the video. All you need to do is know this formula. Carry this thing, insert it inside this here, the answer will flow naturally. Look at what I'm saying. Now they want you to calculate the T2. So all you need to do here is, this is the formula for T2. So this is the formula for the K2. K2 is equal to K1 E, the activation energy all over R, into 1 all over T2 minus 1 all over T1. Now insert it. Our K1 here is 5.76 times 10 raised to the power of minus 3. E, your activation energy given is 52.04 times 10 raised to the power of 3 all over, this is 6.314. This is the constant also, the universal constant, and it equals 6.314. Then, of course, this is open bracket 1 all over 328 minus 1 all over 313. Now, punch this into your calculator straight. Immediately, don't waste time, because like I said, in K131 is either an OBJ or dash. So all they need is the answer. So from there, I've already set it, punch it in your calculator straight. And what you should get is 1.44 times 10 raised to the power minus 2 molarity per second. That should be your answer. Now, let me confuse those that have not been watching my video, the part 1. This answer, the K2, can be written as 1.44 times 10 raised to the power minus 2 mole liter minus 1 F minus 1. Also the same thing. If you have been following my channel, you should understand that that is the same thing. Now let's go to example number 2. As you can see from the board, at this, the temperature one is given, I wrote it here, you have to add plus 273 to convert it to Kelvin. And the first rate constant is given, and the second one was also given. I've written it at the board. The activation energy given. They want you to calculate T2. So all you need to do is write down your formula here. Now T2 is 1 over your T1 is 873. Minus your R is 8.314. Length, your K2 is 4.5 times 10 to the power minus 2 all over your K1 is 2.3 times 10 to the power minus 2. Now everything here, look at the formula here. Divided by the activation energy 117.2. You will never even make this mistake. This formula, everything here is raised to minus 1. It means that immediately you punch your calculator, whatever answer you get from this bracket, you have to do 1 all over the answer to get your T2. You will not make this mistake. I will repeat again. In this my formula here, whenever you punch your calculator and get this answer that is here, you have to do 1 divided by that answer to get the real answer. Don't make that mistake, please. And if you punch it in your calculator very well, your T2 is going to be 911 Kelvin. Now you can still convert it to centigrade if you want. All you need to do is minus 273 from the answer, and you should get like 638 degrees centigrade. So know this very well, and that is it for this question. Please be conversant with what I just did. Remember, I said raise your answer after punching that bracket to minus 1 when you are trying to calculate your T2. We have the third question at the board. The rate of a second order reaction was found to be this and this. So K1 and K2 given. At the first initial temperature given, calculate the activation energy. Now, they have given you the first temperature. They gave you the second temperature. Now, the rate of a second order reaction was found to be this. They have given you the rates and this at 20 degrees centigrade and 50 degrees centigrade respectively. Calculate the activation energy. Now you can see that I've already done it at the board. Come to the right hand side of the board and you can see the formula there. So all you need to do is just insert it and you get your answer naturally. Insert it. So the activation energy here is minus 3.314. Length, your K2 is 3.64 times 10 to the minus 3 all over 1.56 times 10 to the minus 4. Then everything here divided by 1 all over your T2 323 minus 1 all over 293. So if you punch it very well, your activation energy will give you 82 points. 82 points. 82630 122 joules per mole. Now it can be 82 points 63 kilojoules per mole. So whichever one. Of course, how can you get kilojoules per mole is when you divide by 1000. You will get it in kilojoules per mole. So that should be all for this video. Please, as you are watching our video, comment, drop a comment, give us a thumbs up. We really appreciate it.